All right, we're going to be going through ionic and metallic bonding today, a little bit of a review on ionic, and then starting into metallic. What we've been talking about lately is this idea of attracting. Opposites attract each other, right? We've talked about it in terms of the relationship. We've seen it with magnets and the fact that the opposites attract there. We've talked about how the protons, positive, attract the negatively charged electrons. Of course, just this idea of opposites attract goes into a lot of different other areas of our lives that we've heard about. The big movement or the big push for you today is to switch your thinking and move your thinking from what's going on inside the atom to now what's going on outside of the atom. Inside of the atom, we were talking about those attractive forces between the nucleus and those outer electrons. And we also talked about how the electrons themselves push away from each other. They want to be as far apart as they can within those orbitals, which is why we talked about, like in Hund's rule, the empty bus seat rule, that they each fill each orbital one at a time, then move from there. So now we're switching to this idea of the atoms attracting to each other. So not what's happening within the atom, but the atoms attracting to each other. What's going on the outside there. So the first type of bond that we went over is ionic. And with ionic bonding, we said that, there's just one atom and it's going to be giving its electron away. And so we've got sodium and chlorine here as good examples. Sodium saying, just take it please, and chlorine saying, I don't mind if I do. Going ahead and accepting that electron there. So in this depiction here, we see that sodium then becomes labeled as a cation with a positive charge because it got rid of its electron, and then chlorine gaining that electron, becoming an anion with a negative charge. And so while this cartoon here does a good job of representing what's happening, I actually like to think about it a little bit differently. So when I think about it as this relationship here between sodium and chlorine. So here's sodium saying, will you make me complete and accept this electron? And then we've got chlorine saying, hooray, of course I'll accept it, you complete me. So more of a, instead of sodium running away from chlorine scared, it's actually more of like a proposing situation where it's offering its electron to chlorine because sodium wants to get rid of its electron as well. And now, because of this giving and receiving that's happened between sodium and chlorine, they now have this attraction to one another, kind of like what would happen if you were being proposed to. And if we want to be even more specific about this attraction that's now between them, we would call it electrostatic attraction, because sodium has that positive charge and chlorine has that negative charge. So like we just said, opposites attract. That idea of this opposites attracting is just going to kind of keep coming back around. So how does this then apply to this new idea of metallic bonding and what's going on there? Well, with metallic bonds, all metals are givers of electrons, just like our sodium, who was wanting to get rid of his electron or propose to chlorine. All of the metals are wanting to give their electrons. So they're kind of donating their electrons. They're all going to be giving those electrons away. So what happens then if there's no one to receive the electrons? Well, those electrons kind of end up just floating in a big pool or a big sea out in between the metal atoms. So here we've got our metal atoms, and they're just swimming around in this sea of electrons. There's no one to receive the electron, so the electrons just hang out. But remember, this idea of this negative electrons just kind of hanging out in this empty space, this actually gives metals the characteristics that we know and really rely on in our world. So the characteristics of metals, some of the most common ones that we talk about are malleability, ductility, and conductivity. And those might be words that you're not familiar with, but malleability is just the ability of metal to be hammered into sheets. So aluminum foil, which we should all be very familiar with, that's this idea of malleability. Aluminum, a metal, is able to be hammered out into sheets. Why is it able to be hammered out into sheets? It goes back to this idea of these electrons being in this sea. If we hammered on these electrons, or on this metal, these electrons would simply move around within the sea, and the atoms could be smushed closer to one another because there's not a bond, a tight bond there. The electrons are just able to kind of move around, and the metal is able to be hammered out into a sheet. The other one is ductility, and that's along with this same idea that you can mold and shape the metal because the electrons are just in this sea between the metal atoms. It allows them to be also not only hammered out into sheets, but pulled and twisted out into wires, which is where all of our metal wiring that we rely on comes from. And then the final characteristic is conductivity. And conductivity is shown here, where a metal is able to complete a circuit and allow electricity to flow through it. And once again, this all comes back to this idea that their electrons are all just being donated out into this sea that's just kind of hanging out there and flowing. The first picture here, you've got a coin, a metal coin that's completing this circuit, allowing electricity to flow through it, and like the light bulb. In the second picture, you have a paper clip that is allowing the electrons or the electricity to flow through it, and like the light bulb. So again, just like the attraction that was happening in our ionic bond between the cation and the anion, we have that same attraction happening in our metallic bond. That electrostatic attraction between the positive cations, the metals that have now donated their electrons out to this sea, and the negative electrons. Still that positive and negative idea of opposites attract. I hope this helps you to gain a better understanding of ionic bonds and serve as an introduction to metallics.